Hello, Richard here. Welcome to part 3 of fixing the saddle on the Mini Lathe. Now, if you've been following along so far, you'll know that we've basically taken the saddle on the Mini Lathe here and we've sort of fixed all the wrong geometry. We've got it all flat, level and all sort of nicely leveled up and ready to put back together. And the final thing remaining is to sort out the gib strips. Now, I said before that these appear to be made of steel and they're not very nice. And the plan was to make some new ones of these. For that, I was going to be taking this, which is an old base from a scrapped bench drill, and I was going to, by hand, cut this up into pieces and make new gib strips. Well, that sounds like a lot of work, doesn't it? So what I thought was, let's just test these and see if they actually are steel or if they're cast iron. Now, if they're cast iron, I can scrape them flat and I can sort of titivate them somewhat. Whereas if they're steel, not so easy, not so nice to scrape. So I did a spark test and turns out they're cast iron. So I don't know how well you can see that. I scraped that one in and got it flat. So a complete U-turn on what we said last time. I'm not going to hand make some gibs out of the old bench drill. I'm just going to scrape these flat and put these back on. So that saves a lot of time and effort, which is a good thing because I wanted this to be a fairly quick fix. And we're only 3 episodes in, so that's quick, isn't it? That's quicker than usual. So I've got this one done. What I'll do, I've got one more to do. I've got this one to sort of scrape. This is just, you can see it's got the sort of just the black kind of scale finish on it. So what we'll do, we'll scrape this in, get it flat, and then we can see about actually getting this thing all put back together and working again. All right, let's get scraping. Well, I scraped in the first gib strip while I was working out what material it was. So this one's all nice and flat, and this one's ready to go back on. But what we need to do now is to scrape in the second one for the other side. I've got it held in the vise, so what we're going to do is give this a rough scrape a few times just to get it leveled, and then we can get it over onto the surface plate over there and put some glue down, and we'll see how level we are. And it won't take long to get this flat. It's just going to be flat, and that's all. And then we'll be looking at reassembling the lathe. I've given it a scrape in that direction, so now what I need to do is come back on the next pass at the opposite direction at 90 degrees to the first one, and we'll give this a scrape this way. I don't know if you can see it on the camera at all, but I'm starting to see now slight machining marks, little horizontal marks along here. So they'll clean up eventually and we won't have any marks on there at all. I'm going to give it another pass, so we'll come back this way and then this way, and then we'll be good for some blue. Right, so we'll get some blue on the surface plate. Just put a little bit of this out on here. That's probably way too much. This stuff goes a long way. And then what I'm going to do is move this out of the way. Clean this off. Just get rid of any little particles with your fingers. And using a roller, I'm just going to pick up a bit of the blue. And we'll apply a little bit in the middle. Like I said before, this is a lot easier if you kind of lift up the roller at the end of each forward and backward stroke. See, it spreads a lot quicker if you do that. So we'll just arrange a little bit in the middle. And then once it's sort of spread, we can just keep this held down, get a bit of blue on there. That'll probably do for the initial pass. And then we'll take our gib, put it down, face down, and see where we are. Now, if we rotate it, you can see it wants to sort of spin around the middle. Ideally, if this was fairly flat, it would spin about a third of the way in on each end. So if I did that, it would spin about there. And if I did this, it would spin around this point, but it's spinning in the middle, which suggests that it's not flat. So what I'm going to do is just put my finger in the middle and just gently move it around a little bit. And we'll take a look. And there you can see we've just got contact right in that center piece, because this is actually bent. If I get a straight edge and I put this on here, you're probably not going to be able to see it on the camera, but there's actually daylight behind there. Let me see if I can get a bit of light on there. So I've got the torch on my phone, and if I hold this over here, we'll just see whether you can kind of see. I'm holding it level at this end where my thumb is. Oops. And then if I move that around, you can see there's daylight coming through all the way up that end. So this is quite bowed. What we need to do now is kind of rough quite a bit of material off that middle blue bit where you can see it's blue. So I'm just going to go off and rough that down a bit, and then we'll come back and see where we end up. Now, I've given this about 3 or 4 passes now, focusing just on the middle bit here, sort of probably about that wide of a scrape on the middle. So let's just have a look at it, how it rocks. So it's still rocking a little bit, and get it on the blue and give it a little bit of a rub around on the blue, and we'll see where this ends up. You can see it's spread out a little wider than it was, but it's still high in the middle, and we need to take that down. So go and scrape this down, and we'll come back in a moment. Right, I've done a few more passes, and this is the blue pattern we got at the moment. So you can see that it's starting to come in and flatten off in the middle, and we got a little bit of it. Let me get that out of the light for you. We got a little bit of a low spot here at this end, and this is a little low. I'm scraping quite heavily on this just to sort of get it roughed down to be flat. There's no point having finesse at this stage. So I'll scrape a bit more, and then I'll bring you back in a moment. All right, that's a few more passes. So let's get an imprint and see how we're doing. Just barely using any pressure on this, not pressing it down at all. So you can see how the blue pattern shifted now. If I move it around a little bit, hopefully you can see that. So it's fairly even contact over this area, a little low that end and a little low at that end. Might be picking up a tiny bit of blue on the right hand side. Hard to tell, but we'll keep going. Okay, well, we're really starting to get somewhere now. The blue pattern is pretty much over this entire middle piece. There's slightly high just here and slightly high just here, or low, depending which way up you are. But the blue's the high spot, so we need to knock the blue bits down, and we're not that far off. So hopefully this will come in fairly quickly now. So it's probably been another sort of 15 minutes or so, 15, 20 minutes perhaps. And now we're getting this. So you can see we've got blue over pretty much all of the area. You can see the blue goes right up to the right-hand side and right up to the left-hand side, and over most of the in-between bits as well. So that's pretty much flat now. All I need to do now is, rather than sort of really roughly scraping the area, I'm just going to start knocking down the actual blue spots and see if we can get the blue to creep over a little bit more of the area. But I mean, that would probably do it even as it is. That's probably good enough for what we want, but we'll refine it a little bit more, and I'll show you what the result is. Well, this is pretty much the final state of play. I don't know how well you can see that, but we got blue over most of the area, and I'm fairly happy with the pattern there as well. It's fairly well broken up. And what I'm going to do, I'm just going to wipe this off, and I'll show you how it hinges now. Let me just do that. Right, so I've just taken the blue off, and what we'll do is we'll put it down here. And if you remember last time when we hinged it around and rotated it, it rotated around the middle point. And what you want is for it to rotate or hinge about 2/3 in. So if I hinge it from this end, you can see now it's rotating around here. And then if I do it from this end, it's rotating probably about here. So we're about right on the hinging, and that all looks pretty good. Before we wrap up, what I'll do, I'm just going to get another coat of blue on here. So we'll just level out the blue a little bit, and we'll take an imprint. And what I want to do is just show you some of the sort of the finessing of the blue. It doesn't really need it here, but I just want to show you some of the other tools I've been using. So if we take an imprint, you can see we've got our blue pattern there. What I'll do, I'll just take you back over to the vise and I'll show you some of the other tools I've been using to scrape this with. Right, for the bulk of the scraping, I've been using this carbide tipped scraper, which got this from a guy on, he's actually on YouTube, and he's called the Impractical Machinist. And he sells these on eBay. These are really hard to find in the UK. You basically can't buy these new. Sandvik make one, or Sandvik used to make one. I think they called it the Coromant. And if I remember rightly, it's the 620-20. I'll put some information in the description if I remember with that. But yeah, so I bought this because carbide just doesn't go blunt like steel does. Another one that I use is this one. This came from RDG Tools on eBay. They're a UK company. I have no affiliation with them. I just use them because they're good for supplying tools. This is a steel scraper, and I did a lot of scraping with this, but they just go blunt all the time. They're forever sharpening the things and regrinding the tip. So like if you're doing something this size, this is a whetstone, but or an oil stone. But if you did something this size, you might have to regrind that twice whilst doing that. You might get away with one pass over a surface that big. So yeah, really labour intensive. The one I use for finessing though is this one. This I got this from a car boot sale. This is a Moore and Wright steel scraper. And this one I've reground the end. I don't know how well you can see that, but I've sort of reprofiled the end to be more like a knife blade. It's still got a 5-degree rake on it as usual. It's just a bit finer, and I've got a slightly tighter radius on it. So that makes it easier for finessing things. So what I'm going to do, I'm just going to quickly show you how I would finesse a surface like this, just to break up the dot pattern a little bit more. And then we're going to call it done. So what I do on a surface like this, notice as well, I've got this in a vise and it's done up very, very loosely. Yeah, if you're scraping something like this, you don't want to put it in a vise and graunch it up really tight because you'll actually bend the part and then you're not scraping it flat. So it's just loose, lightly held so as to not impart too much twist. And you see the twist on the surface plate anyway, but worth noting that. So all I do here is I take this little finer scraper, and then all I'm looking to do really is just kind of break up these blue points. And you've got a little bit too loose in the vise there. Yeah, just basically splitting the blue spots in half with that, just going around very gently, just finessing the finish on it. And this is really more for oil retention. You know, it's flat enough, but each little divot that you scrape into the surface there just provides a little pocket for oil to sit. And so for things like ways and gibs, just gives me a superior finish for retaining oil and keeping oil between the surfaces. So that's kind of it, really. I would do that. I would then probably just maybe give it another pass the other way, just hitting the blue spots. And then we'd call that done. Give it a bit of a wipe over. Maybe get a stone and give it a little rub just to get rid of any imperfections. And there you go. Got a nice, shiny, glistening, pearly looking scraped finish on the gib. And that's ready to go back in the lathe. Well, it's time to start putting things back together. So, I've got my box of bits here, and I got me nicely leveled up and fettled up saddle. So the first thing to do really is going to be to refit these studs. And what I'm going to do with that is put a bit of Loctite 641 on there. No other reason, and that's all I got is Loctite 641 retaining compound. So it seemed to work last time. Had a job getting the studs out before, so we'll give this a bit of a go. Okay, that's the first one. I won't bore you with putting in all 6 studs, so I'll bring you back when I've got all those put back in. Right, that's all the studs refitted. So next will be to get it on the lathe, and then we can get the gibs in place. The next thing we need to do is put the lathe back together. So we've got the saddle on the bed there. What we need to do is get the gibs, or the gib strips rather, and then get these fitted back on. If I put this on here, if I put the gib strip underneath the apron, have a look at this, you can see that the gib strip looks pretty level with the bottom of the bed and also the bottom shoulder of the apron. So what I'm going to do on this particular side is we'll just bolt this on as it is and see how tight it goes. If it goes too tight, then I'll put a little shim in between here just to space it off a little bit. And what I'm looking for is sort of zero play but fairly free movement. So that's the plan on that side. Now on the opposite side it's similar, but what happened on the other side is that this bottom bedway here, the underside of here, is actually lower than the bottom shoulder on the apron. So that's why before, if you remember, we were getting the gib strip was sort of kicked over like that. And if you look at part one of the video, you can see before we took it off that that was the case. So what I need to do on this one is step the gib strip off a bit, put a shim in to step it down a bit. So on the other side, what I did was I just got a feeler gauge, holding the gib strip underneath the bedway, created a gap, and I used a feeler gauge to measure the gap, and it came out at about 0.7 millimeters. I measured it with a caliper as well, so all I did there was I took a caliper and I just measured the gap on that, and that came in about 0.7 mil as a sanity check as well. So then what I did, let me move this out of the way. So what I did was I got online and I bought a piece of 0.7 millimeter feeler gauge. Cost me about £5 UK, probably the equivalent to about $5. So I've got a length of 0.7 mil feeler gauge. So although it's got a few little rust spots on there, that doesn't matter. So that's going to be precisely 0.7 mil. And so on the other side, we'll basically make up a shim that's going to space the other side off. But what we'll do, we'll get this first side on to begin with, see how free that looks, and then we'll work on the other side after that. I bolted the front gib on the saddle, and it's tight, but it's not mega tight. And basically now the saddle doesn't move at all. So that tells me that this needs a little bit of shimming just under here. So what I'll probably do is put some thin brass shim in there, try it again, and we'll just adjust it until it moves freely. I could just slacken off the bolts and do that, but I'd rather that this was level and not relying on just any sort of like looseness to make it work. So we'll put a shim in there and see how we get on from there. Right, so I've been having a bit of a play around with things, and tightening the gib strip up on the front without a shim was too tight. So what I've done, I've basically spaced off the gib strip here with these feeler gauges. So you've got 3 feeler gauges in there. They're all 0.5 millimeters. And all I've done for that is I've just basically taken my feeler gauges and I've taken them apart, so I've got individual sort of precision thickness gauges I can use. Now, spacing this off by 0.5 millimeters, so if you look down here, this gap now between the gib strip and the shoulder of the apron, that's now 0.5 millimeter. So what I can do now is I can take this 0.4 millimeter feeler gauge and I can pop that in there, the gap between the gib strip and the bed. See if I can get that so you can see it. So basically the gap in here between the gib strip and the underneath of the bedway, the lathe bed itself, that feels like it's about 0.4 millimeters. That gauge kind of goes in there, and you know, they're called feeler gauges because you put them in, you sort of feel how they fit, and that feels a little bit of resistance. That feels about 0.4 millimeters. And if I come around the other side, you'll have to sort of take my word for this. Around the other side here, this also feels at about 0.4 millimeters. So what we're saying is, if I've spaced the gib strip off by 0.5 millimeter and the gap now is 0.4, that means that I need a 0.1 millimeter shim in between the apron and the gib strip. So that's the geometry and the arithmetic. So if I make myself a 0.1 millimeter or thereabouts brass shim, then that should get us in the ballpark. Now, I don't know how well you can see this now, but we've got a little brass shim that I fitted under here, just a 0.1 mil brass shim, just cut out of some 0.1 mil brass shim stock, just cut out with scissors, easy enough. So that's in there. The bolts are up nice and tight now. They're not graunched up, you know, they're not white knuckle tight, the bolts under here. So bolts nuts, I meant. The nuts aren't that tight. They're just sort of, you know, they're tight enough, tight as they need to be. They're certainly not loose. Anyway, so now with a 0.1 mil shim under there, we have this. So now we have nice movement, and we don't seem to have any kind of play, not that I can detect by wobbling by hand anyway. So that looks like the front's sorted out. It's moving quite freely. Even up to, it stiffens up right under the chuck, but if I get it that far up the chuck, I've got bigger problems than this, so let's face it. So, right, that's good. I'm going to call that done on the front. So now what we need to do is, rummages on the desk a moment, here we go. We need to take this and cut a shim out of this, which won't be done with scissors. This is going to probably need a Dremel. So we'll grind this into some sort of shim, fit this in the back, and then see how close we are. Now to trim down this feeler gauge, which is hardened steel, I'm just going to use a cut-off disc on the trusty Dremel. Dremels are great. I mean, I really like Dremels. I don't use them all that often, but sometimes they're just a tool for the job. But one of the things that really bugs me about the Dremel is the cord. It's made out of Bakelite. It's so stiff, you know, it just gets everywhere. So this could really do with a nice sort of supple silicone rubber mains cord. Maybe it's a job I'll do one day. But yeah, anyway, let's see if we can get this cut down to size and make a shim strip. So my next problem was how to drill holes in a piece of hardened steel, and options were things like anneal the metal with some heat, which I don't really have any way of heating it up at the moment. So I could anneal it, drill it, harden it again. That's a bit round the houses. You can cut hardened steel using masonry drills if you've got a bench drill. I don't have a bench drill at the moment. So what I thought was I'd have a go with this on the Dremel. I've just got a little diamond burr that came in one of those sort of Dremel toolkits. So well, you can see that on the end, just a little diamond ball, and that's actually not doing a bad job of just wearing some holes through. It's not the prettiest way of doing it, I must admit, but it gets the job done. And I'll need to open them up a bit, but I'll put a different size burr in, and we'll do that. But I'll just show you how that works, really. It's not as bad as it sounds, honest. And there we go. It sort of gets the job done. Just open the holes up with another little conical burr now, and should be good to go. Right, so we've got some holes drilled through this bit of old feeler gauge, and they've been roughed out so they just slip over the studs. It doesn't have to be precision, just has to be the right thickness. But it's got a few burrs on it, so I'm just going to give it a little hone up on a diamond plate just to kind of remove the burrs a bit. I don't want to take any thickness off. This is not going to really take any of the thickness of it off, but it's just going to get it nice and flat and get rid of the burrs so that it doesn't throw the gib strip out when I fit it. So just give that a little deburring over here, just get it nice and flat. Take the sharp edges off. Let's have a look at that. Yeah, that's nice and flat. Okay, so I've got both of the gibs back on. It's all back assembled, or the saddle is at least assembled onto the bed, and looks pretty good. It's moving quite smoothly, and I don't really have much play in there at all. But Houston, we have a problem. When you move the saddle further up the bed, we get to a point where it seizes up and it won't go any further. So if I keep pushing it, yeah, it's going to get tighter and tighter. So we've got a stiff spot up at this end for some reason or other. So what we've got to look at is why is this binding up? Why does it bind up when it gets to that point? So it could be that the bed is bowed, either way. Could be that the bed is twisted. Bear in mind, this is just sat on top of a table, so it's not leveled or anything like that. So there could be a twist in it, maybe. I don't know. It's odd that it kind of suddenly stops there. So yeah, we're going to have to sort of have a look, and we'll take it from there. Right, I've had a good look over the lathe to sort of see what could be causing that binding problem. Now I loosened the gibs off, and that didn't have that great an effect on it. If I slacken the gibs off like this, so they're really loose, then yeah, I can get this up to the end. But I was just getting some strangeness, and as I say, it didn't look like the binding was caused by the warping of the bed. It's fairly minimal. It's not that bad. But what I did notice was, if you look here, I don't know if you can see that very well, but here's the gib. So that's the rear gib. This is where it rides on the underneath of the way. There's a little flat under here, and just look how close the edge of the gib is to this little shoulder here. Now this shouldn't be that close. This vertical edge here shouldn't be rubbing with this vertical edge here, and they're basically touching, and this is with the gib really loose. So what I'm thinking is perhaps this is actually just binding up on this face here, this vertical face here. So maybe the gib's binding on that, and that's what's causing the problem. So what we're going to do, I'll just move this out of the way, and then we'll get a dial indicator on the bed, and we'll see if there's any signs of misalignment that could be causing this to bind up on this part of the way underneath. So let's get that set up, and I'll bring you back in. Now I've got a dial gauge just mag based onto the saddle, and I've got it zeroed as best as I can. So hopefully you can see that from there, that the gauge is on 0. And what we're doing is we're basically measuring the distance between the saddle and the back of the ways here. So if you watch this as I sweep along, and I'll try and keep it fairly consistent if I can. So you can see there, we're up to 0.1 of a millimetre. And now we're up to, well, probably about 0.25 millimetres of discrepancy over the whole range. So let me bring you back over to the top, and then we can talk about what I think the problem is. Right, what I think's happening, or what I think the problem is that this V way here isn't parallel with the back of the ways here. So in other words, if I get my trusty straight edge, what I'm saying is if this is the line of the V, it's kicked out like this. So this means that basically when the saddle moves along, the saddle starts off in a position here, then as it moves up, it's basically moving backwards as it goes. That's then pulling this gib, the front face of this gib, is pulling it into the inside of the ways, which is what I think is causing the binding problem. So I think it's more of a binding problem than things actually being out of whack at the moment. So what I think I'll do, I think I'll take the rear way off, and I'm going to file probably 0.5 mil off the front face of it, put it back together, and well, we'll try again, see where we are then. Right, we've got the saddle back together, got the gibs back on, all snugged up, nice and tight, and we've got free movement. So let's see whether what we did has actually improved this. And drum roll, no, is the answer to whether this has been sorted out. So I think the best thing we can do now is give it a good coat of looking at. Well, nothing that a good old cup of tea won't fix, eh? Further down the rabbit hole we go. I thought we were really getting somewhere then, and no, there's there's still more things wrong. I mean, the thing is with this lathe, the difficulty really is not so much what's wrong with the lathe, it's just trying to work out what's right with it. You know, I mean, I'm not being flippant by saying that. I really mean that it's really hard to know which bits are actually right because there's so much wrong with it. When you're measuring things, you know, is the thing you're measuring, if it's flat, is it supposed to be flat? And if it's bent, is it supposed to be bent? Or so what I've done, I've had a bit of a closer look at what we're up against here. And if you remember back to part one, in part one of the video, I actually measured the thickness of the rear ways here, this thickness here. It measured at about 0.06 of a millimeter of deviation in the sort of parallelity. So in other words, that's probably that's not the best way of phrasing it. The thickness varied by 0.06 of a millimeter, by 0.06 millimeters, which is about 2.5 thou, 2.4 thou. And at the time, I didn't really appreciate the significance of that because, I mean, I suppose everything was so far out that, like I said, what's right and what isn't. So as it is, I think that is really the root cause of the problem. So I think because the thickness of the bed at the back varies, and it starts to vary just about where it binds up. So basically the bed is bent, and we've got to work out what we're going to do about it, if anything. So yeah, we finish my tea, and then we'll give it another coat of looking at.